You have a vial of Texsulfur colloid. It has 50 millicuries and 4 ml at 8 a.m. That's my conversion. 50 millicuries equals 4 ml. I want to draw a 1 millicurie dose now. I want one at 9 a.m. and one at 9:30 a.m. So I'm going to do now first. I need 1 millicurie. I can use my conversion. 50 millicuries, millicuries on bottom because it's on top. 4 mLs on the top. Millicuries cancel. 1 times 4 divided by 50. I have 0.08 ml. Now at 9 o'clock, what happens to my 50 millicuries? That's an hour later. So all I have to do is take that 50 times 0.891. And now my new conversion is 44.6 millicuries equals 4 ml. Again, I need 1 millicurie. I'm going to throw in my conversion. Whatever's on top goes on bottom. 44.6 millicuries, 4 mLs on top. Millicuries cancel. 1 times 4 divided by 44.6. Now I have 0.09 ml. Well, this makes sense, doesn't it? The volume's going up because time is causing it to decay. Now my next one, 9:30. Well, at 9 o'clock I have 44.6. 30-minute decay factor is 0.944. So all I have to do is take that 44.6 times 0.944. Now at 09:30, now I have 42.1 millicuries in 4 ml. I need that 1 millicurie again. By 42.1 millicurie down here, 4 mLs at the top, millicuries cancel. 1 times 4 divided by 42.1, and I have 0.1 ml. All right, let's keep going. You're preparing a dose of Synclide. And Alexis, I very much appreciate you having your camera on because I get to see your facial expression and it helps me identify if you're like totally lost or if you understand. So I'm using you for my timing. And believe it or not, we're like right on time in terms of how many problems we have left and the time we have left. So I'm hoping we're going to get through all these. All right, you're preparing. No pressure on everybody else to turn your cameras on, but it would be nice to meet you guys. All right, you're preparing a dose of Synclide. The vial contains 5 micrograms in 5 ml. Your patient weighs 160 pounds. Hello, Veronica. I think we've met before. All right, your patient weighs 160 pounds. How many mLs do you use? Now, you have to know this conversion because you need to know how much we give our patient. What do we give for Synclide? CCK, 0.02 micrograms per kilogram. So, we're in pounds. I have to convert my pounds, 160 pounds divided by 2.2 to give me kilograms. That comes out to 72.7 kilograms. Now, this is a conversion. 0.02 micrograms equals 1 kilogram. I'm at kilograms, so I can use that conversion. 72.7 kilograms. Whatever's on top goes on bottom. Put my micrograms up here, 0.02. Kilograms cancel. Take my 72.7 times 0.02, and I have 1.5 micrograms. It asks how many mLs. My conversion is 5 micrograms in 5 ml. I can write this in here if I want to. Whatever's on top goes on bottom, micrograms, ml. 5 micrograms is 5 ml. Since it's a 1-to-1 ratio, you're multiplying it by 1. So it's still it's actually 1.5. 1.5 ml. Very good. All right, let's do another one. Dipyridamol. Everybody knows the dose of dipyridamol, right? Everybody knows 0.56 milligrams equals 1 kilogram. Milligrams per kilogram. Per just means you put an equal there. So, I have a vial of dipyridamol. It has 50 milligrams in 10 ml. Oh, that's another conversion. 50 milligrams equals 10 ml. My patient weighs 120 pounds. I wanna know how many milligrams and how many mLs. So the first thing I'm gonna do is convert my 120 pounds divided by 2.2, that's gonna give me kilograms. 120 divided by 2.2, I've got 54.5 kilograms. Now my dose, I'm gonna start with our 54.5 kilograms. I'm gonna put in my conversion for kilogram on the bottom, milligrams on the top. I'm gonna use this conversion first because I'm starting with kilograms. I can't use this conversion yet because I don't have kilograms. Again, these are doorways. You have to use the doorway that's available to you, and this one's available. So I'm gonna put my 0.56 milligrams up here, my kilogram down here. Kilograms cancel. I'm given 30.5 milligrams. I'm halfway done. 30.5 milligrams. Look, now this doorway's open to me because it has milligrams. So I'm gonna put milligrams on the bottom, ml on the top. I just put in my numbers, 50 milligram, 10 ml, milligrams cancel. 30.5 times 10 divided by 50, 6.1 ml. Those are my two answers. So when you get a problem like this, don't get overwhelmed. Find your conversions and write them down. Start with what you're given, and then use the doorway that is available to you. If none are available, then find out how to get to the doorway. Because we actually started with 120 pounds, so we didn't have a doorway available to us. We had to get to kilograms in order to use that doorway. All right, kit preparation. You're preparing a kit of Tech MAA. You need the following doses. You need 2 millicuries right now. And then you need 5 millicuries in 5 hours. So I want to know how much to put in my Tech MAA kit. So I have 2 millicuries now. I don't have to do anything with that, right? That's just 2 millicuries. But I need 5 millicuries in 5 hours. So that means I need to put more in now, so I have 5 millicuries in 5 hours. 1 hour decay factor, right? 5 millicuries divided by 1 hour is 0.891. This is 5 hours, but I put it to the fifth. Let's see what we get. 5 divided by 0.891, up caret, 5, get 8.9 millicuries. So my answer is the 2 millicuries I need now, and the 8.9, which is going to give me 5 millicuries later. I need to put 10.9 millicuries in this vial to have everything I need. Okay. You're preparing Tech MDP. You're preparing it at 0800, and you want 3 doses. Each dose is going to be 22 millicuries. You need a dose at 0900, 1000, and 1130. What is the minimum amount of activity to put in your kit? So each one of these, I know I'm going to have to put more than 22 millicuries in order to have that amount at the time I need it. So I'm going to do my 0900 first. I'm going to take my 22 millicuries, and I'm going to divide it. I'm going to divide it by the decay factor because I know I need more than 22 millicuries. There's 1 hour between 0800 and 0900, so I'm just going to divide it by 0.891. 22 divided by 0.891, we get 24.7 millicuries. Now at 1000, take my 22 millicuries. Now there's 2 hours between 0800 and 1000, so divided by 0.891 squared. 22 divided by 0.891, up caret 2, 27.7 millicuries. And now 1130. This is the tricky one. 22 millicuries. There's 3.5 hours, so 0.891 to the third. Then I have to put in my half hour of 0.944. So you can do 22 divided by 0.891 up caret 3 equals divided by 0.944. Do not hit times. Okay, make sure you divide by both of these. And you should get an answer of 32.9 millicuries. So your answer is add all three of those up. That's what you put in the vial at 0800 to make sure you get those doses at each time that you need them. All right, one more, and then we're going to move on to something different because this is heavy. You're preparing a kit of Tech MDP. The eluate you're using has 500 millicuries in 10 ml. I have to draw a picture. Here's my vial. I have 500 millicuries in 10 ml, and this is my technetium. All right, I want to add into my Tech MDP, this is my MDP kit, I want to add 100 millicuries, and I want there to be 5 mLs. So the question is, how much of this Tech eluate should you use? And then, how many mLs of saline? Don't even think about the mLs of saline for right now. Just think about how much technetium am I going to put in. So I want 100 millicuries. My conversion is 500 millicuries equals 10 ml, because that's what I'm pulling it out of. So whatever's on top goes on bottom. I'll put my mLs on top. 500 millicuries is 10 ml. Millicuries cancel. 100 times 10 divided by 500, that's 2 mLs. That means if I pull 100 millicuries out of my Tech eluate, it equals 2 mLs. So now I have 100 millicuries and I have 2 mLs, but I want a total of 5 ml. Well, the second part of the question is, how many mLs of saline, diluent, do you want to put in? If I have 2 mLs in there, I need to add 3 more, so I have 5 ml. So sometimes just drawing pictures allows it to make a little bit more sense. All right, let's switch gears. Now, activity per weight. Again, conversion problems. We have a radiopharmaceutical. It has a pediatric dose protocol of 0.05 millicuries per kilogram. That means 0.05 millicuries equals 1 kilogram. My patient weighs 75 pounds. How many millicuries should they receive? This is my doorway, but I'm starting in pounds, so I can't go through my doorway yet. I can't go through it until I have one of these variables. I know I can convert pounds to kilograms. So 75 divided by 2.2, I have 34.1 kilograms. Now I'm at kilograms, so I can use my doorway. Whatever's on top goes on bottom. Millicuries on top. 0.05 millicuries, 1 kilogram. Kilogram cancels. 34.1 times 0.05. My dose is 1.7 millicuries. All right, let's do another one. Pediatric dose for a given scan is 100 microcuries per pound, so that's my conversion. 100 microcuries equals 1 pound. My patient weighs 50 pounds. I'm already at my conversion, so I can go right through the doorway. 1 pound is 100 microcuries, not millicuries. I was looking at that, I was like, wait a minute, we're going to give them 500 millicuries? Microcuries. Whew. All right, pounds cancel. 50 times 100 divided by 1. Equals 5,000 microcuries. But it asks for millicuries. Well, we've already done this, right? We know how to convert microcuries to millicuries. Whatever's on top goes on bottom. Millicurie on top, 1,000 to the smaller unit. 5,000 divided by 1,000 is 5. 5 millicuries. And then it says, how many megabecquerel? Well, we've done that too, because we know that 1 millicurie is 37 megabecquerels. So we start with our 5 millicuries. Whatever's on top goes on bottom. Megabecquerels on top. 1 millicurie, 37 megabecquerels. 5 times 37. We have 185 megabecquerel. All right. What if you're not given, or you don't know, the pediatric dose? We can use something called Clark's formula. I have no idea who Clark is. I need to find out. So Clark's formula, and then Clark's a liar too, because Clark basically says that the average human being is 150 pounds, and I beg to differ. So 150 pounds equals the adult dose. So that is your conversion. So in this equation, 20 millicuries is the adult dose. So that means 20 millicuries equals 150 pounds. My patient weighs 40 pounds. Start with what I'm given. 40 pounds, whatever's on top goes on bottom. Millicuries on top. 150 pounds on the bottom, 20 millicuries on top. Pounds cancel. 40 times 20 divided by 150. We have 5.3 millicuries. We can do the same thing here. 4 millicuries is the adult dose. That means 4 millicuries equals 150 pounds. 80-pound patient. Put my 150 pounds on the bottom, 4 millicuries on the top. Pounds cancel. 80 times 4 divided by 150. 2.1 millicurie is my answer. Now, Clark's formula, again, is 150 pounds equals the adult dose. That's my doorway. If I've given the weight in kilograms, then I have to get to pounds first. Now, we know pounds divided by 2.2 is kilograms, so the opposite is true. Kilograms times 2.2 is pounds. So if I take my 15 kilograms times 2.2, I have 33 pounds. Again, 150 pounds in the denominator, 10 millicuries is my adult dose. Pounds cancel. 33 times 10 divided by 150. My dose is 2.2 millicuries. Same thing here, 4.5 kilograms, 4.5 times 2.2. We have 9.9 pounds. That's a newborn baby. We'll do a gastric emptying study, I think. All right. 1 millicurie is the adult dose. 150 pounds in the denominator, pounds cancel. 9.9 times 1 divided by 150. Patient's getting 0.07 millicuries, or 70 microcuries. All right, MAA particle calculations. I get students all the time, and I'm like, I just don't understand MAA particle calculations. It's like, well, you understand dose volume. It's the exact same thing. We're just adding one more variable. Okay, you have a Tech MAA kit. It has 2,500,000 particles. It has 200 millicuries and 10 ml. What does that mean? That means that all three of these things equal each other. In this vial, I have 2,500,000 particles. I have 200 millicuries, and I have 10 ml. Those all equal each other. It's like one big conversion. And all I have to do is take what I need. Okay? I don't have, just because it's given to me, doesn't mean that I have to use it. So the question is, how many particles will be in a 3 millicurie dose? So I'm going to start with my 3 millicuries. Whatever's on top goes on bottom. Now I have to go into my vial, and I'm only going to take what I need. I need millicuries, because I start with millicuries. So what do I have? I have 200 millicuries. It's asking me for particles. So I'm just going to put particles up here. And I'm going to go in and see how many particles I have. I have 2,500,000 particles. Millicuries cancel. I'm left with particles. 3 times 2,500,000 divided by 200. My answer is 37,500 particles. So that 10 ml was useless information. I don't need it. Let's do another one. You have a Tech MAA kit with 4 million particles, 75 millicuries, and 8 ml. They all equal each other. You want a 2 millicurie dose. How many mLs is that? So I'm going to start with what I'm given, 2 millicuries. Whatever's on top goes on bottom. So I'm going to go and find out what my millicuries, that's 75. On top is what it's asking for. It's asking for ml. So I'm just going to put ml up here. And I go in my problem, find my mLs. Millicuries cancel. I'm left with ml. 2 times 8 divided by 75. ml. All right, you have a vial of TechMAA with 3 million particles, 100 millicuries, and 8 ml. You want a 4 millicurie dose. How many ml and how many particles? All right, so it wants me to do two problems, and I can do this. So I'm going to start with my 4 millicuries. Whatever's on top goes on bottom. I go out and find my millicuries. It's 100 millicuries. First question is, how many ml? So I'm going to put the mLs up here. Go find my mLs. It's 8 mLs. Millicuries cancel. 4 times 8 divided by 100. 0.3 ml. Now I'm going to do the same thing except for particles. Still a 4 millicurie dose. Whatever's on top goes on bottom, so I'll put my 100 millicuries down here, but now I'm going to put my 3 million particles on the top. Millicuries cancel, I'm left with particles. 4 times 3 million divided by 100, 120,000 particles. Now you could have also started with the 0.3. And you could have said, oh, well, maybe I have a 0.3 ml dose. Then my conversion would be ml here and particles here. mLs, 8 mLs. Still going to put my 3 million particles here. mLs cancel, and you're still going to get 120,000 particles. So it works both ways. You could have started with the 0.3, or you could start with the 4 millicuries, because at that point, those two things equal each other. All right, let's do another one. Last one on this, then we're going to move on to generators. You're making a TechMAA kit. You have 4 million particles. You want to ensure that your dose of 4 millicuries has less than 60,000 particles. This sounds incredibly confusing. What is the minimum amount of activity that you need to add to this kit? Whenever you get a problem and you're just like totally confused about it, find your conversion. What's my conversion? I want a 4 millicurie dose, okay? The dose that I give my patient, I want that 4 millicuries to equal 60,000 particles. That's my conversion. What else do I have here? I've got 4 million particles that is in my vial. So I'm going to start with my 4 million particles. Whenever you get stuck, always say, Sybil told me whatever's on top goes on bottom. So just do that, because if you just do that, it'll nudge you past your stuck point. I'm going to put the particles on the bottom. And now I have my conversion. I have my doorway. So I'm going to put those 60,000 particles down here. And it's asking me how much activity, so I'm going to put my 4 millicuries up here. Particles cancel. So 4 million particles times 4 divided by 60,000. I need to put 267 millicuries in that vial in order to pull out a dose of 4 millicuries and have 60,000 particles. All right, let's talk about generators. Generator yield. There's theoretical yield and actual yield. Theoretical is you're looking at this generator, you're like, I wonder how much is in there. In theory, there is this much in there. Actual yield, you milk the generator, that's what you actually get. Now we want to do a theoretical yield because we might be a pharmacy with 4 or 5 generators and we want to know, I just need about 200 millicuries, which is the best generator to milk. So we have to understand what's happening in our generator. The moly is decaying. It's decaying at a steady rate. We can always calculate exactly how much moly we have because moly's never coming out. The technetium is going to be increasing as moly decays and then it drops at the same rate. So if we can always tell how much moly we have, and if we're given the ratio between tech and moly, we can figure that out. So this particular problem says we eluted the generator 8 hours ago, and at that time it had 2,900 millicuries of moly. So we're about right here at 8 hours. First, we're going to calculate this point. How much moly is there? We have 2,000 millicuries 8 hours ago, so we're going to decay. 2,900 e to negative 0.693. Half-life is either 66 or 67 hours, depending on what book you prescribe. we're gonna go with 67 times 8. Plug that in your calculator. I get 2,670 millicuries of moly. I found this right here. Now, it says my tech moly ratio is 0.537. What that means is for every millicurie of moly, I have 0.537 of technetium. So all I have to do is multiply how much moly I have by my ratio. I have 1,434 millicuries of tech. That's my theoretical yield. That's how much technetium I think I have in there. Let's do another one. Molytech generator was calculated to have 1,400 millicuries now. It was last diluted, no, this is a bad problem, we're skipping that. Molytech generator had 3,000 millicuries at calibration 24 hours ago. We want to know how much can be eluted if the 24-hour tech moly ratio is 0.88. So again, moly's decaying, technetium is increasing, but now we're at 24 hours, so this ratio is much closer. First thing, decay my moly. A sub T equals 3,000, e to negative 0.693 divided by 67 times 24. Throw that in your calculator. We have 2,341 millicuries of moly. That ratio is 0.88. I have 2,060 millicuries of technetium. That's theoretical yield. Then we have actual yield. So that's the easy one, actually. Theoretical's hard, actual's easy. Theoretical yield is 250 millicuries. I think I have 250 millicuries in that generator. My efficiency, my elution efficiency is 88%. What is my actual yield? 250 millicuries times 0.88. And we know it's going to be smaller because you're not going to get more activity out than what you think is in there. You're going to get less activity out than what you think is in there. So if you divide it and you get a higher answer, you know you did it wrong. So you know your answer is going to go down. 250 times 0.88 is 220 millicuries. Actual yield. All right. Now, if the theoretical yield is 850 millicuries, and your actual yield is 727, what's the efficiency? Well, we're going to take what we actually got, 727, divided by how much we think is in there, times that by 100,